Okay. Hello everyone. In this slide, what we are going to cover is the characteristic equation, which is very important in realizing the flip-flop from one flip-flop to another flip-flop. Okay. So we will cover the characteristic equation of all the four flip-flops. That is the characteristic equation of SR flip-flop, JK flip-flop, D and T flip-flop. So for this, the basic requirement is you must know how to solve the K-maps. You all know what is 4 variable K-map, what is 3 variable K-map, what is 2 variable K-map. So 4 variable K-map, when 4 variable K-map is used, when there are 16 combinations, when there are 16 input combinations, right? 3 variable K-map, this is the 3 variable K-map, as you can see, Qn, S and R. So this is the 3 variable K-map. When 3 variable K-map is used, when there are 8 combinations. Okay, so to determine the characteristic equation of SR flip-flop, we must have the characteristic table of SR flip-flop. So we have developed the characteristic table of SR flip-flop in the explanation or in the lecture 1 SR flip-flop. Okay, just if you don't know the characteristic table, please refer lecture 1 SR flip-flop. So this is the characteristic table in which Qn is the past output and Qn plus 1 is the next output. So basically we have to determine Qn plus 1. We have to determine Qn plus 1, the equation of Qn plus 1. Okay, for this the inputs are Qn, S and R. And how many combinations are there? There are total 8 combinations. So we will use the 3 variable K-map. 4 variable, it is not required here. So we are not going to use this 4 variable K-map. We are going to use the 3 variable K-map. So this is the 3 variable K-map. As you can see here, 0, 1, 2, 3, 4, 5, 6, 7. You all know how to determine this 0, 1, 2, 3, 4, 5, 6, 7. I have already covered in the lectures. Okay. Now we will fill all the ones. So 1 is on 2, 1 is on 4 and 1 is on 6. So 2, 4 and 6. I have written here 1 and we will fill the don't care condition. So the don't care is on 3 and 7. So 3 and 7, the don't care condition. Now you all know K-maps. If there is a don't care condition, it is not necessary to use all the don't care condition, but if we are using the don't care condition and we are getting the maximum number of pairs, the maximum ones in a pair, then we can use the don't care condition. So here you can see we can make a group of 1, 1, don't care, don't care. This is a 1 group and the another one is the mirror image, 4 and 6, this one. Mirror image, you all know what is a mirror image. If we partition like this, and if we are folding it, that means this and this are overlapping each other. So this is the mirror image. So basically there are 2 groups, one is this and one is the mirror image. So first find the expression for the mirror image. So as you can see, when we are solving the K-map, you all know first we will see at the left and then again we will see at the top. So when we are seeing at the left, it is 0 and 1. There is nothing common, so we are not going to write anything. Okay, now here at the top, it is 1, 1 and 1, 0. So what is the thing which is common? It is 1. So 1 is at first place. So what is at first place? It is S. So for this pair, what will be the expression? The expression is S. Plus, now we are taking the mirror image, this and this. So again we will see at the left. At the left, what is at the left? It is Qn. It is 1. That means Qn. So we will write Qn here. And now at the top, it is 0, 0. And at this one, it is 1 and 0. So in 0, 0 and 1 and 0, what is the thing which is common? It is 0. The thing which is common is 0. That means 0 is at second place. That means I will write R bar. So it is R bar. So what will be my expression? Qn plus 1 equals to S plus R bar Qn. So this. Now the next is the equation for JK flip-flop. Okay, JK flip-flop. For writing the JK flip-flop equation, we must know the characteristic table of JK flip-flop. If you don't know the characteristic table of JK flip-flop, please refer lecture number 2, which gives the explanation on the characteristic table of the JK flip-flop. So again, in this one, there are 3 inputs Qn, J and K. So there are 3 inputs and we have to determine Qn plus 1. So if there are 3 inputs, that means in this also we will use the 8 combinations. That means we will use the 3 variable K map. So this is my 3 variable K map. The inputs are Qn, J and K. Okay. Now again I will write the ones in the K map. So we can see the 1 is at 2, 3, 4 and 6. So 1 is at 4 positions, 2, 3, 4 and 6. So I will write here 1, I will write here 1, I will write here 1 and I will write here 1. Okay. So these are basically 4 ones. Now we will make the pair. So what pair I will use? I will use first the mirror image, this and this and this. And the another pair I will make like this. See this one, you can easily make this pair also, but this is really not required. Why this is not required? Because in the mirror image, this one is already covered. And if I am pairing this one is already covered. So these two ones are already covered in the pairs. So if we make this extra pair, it is really unnecessary and it will make the equation large and it will make the use of more NAND gates. So this pair is not really required. So we will use this mirror image and this pair. Okay, I have shown this so that there will be no confusion. So we will write the equation now for the mirror image. 4 and 6 are forming the mirror image. So we will see at the left. At the left it is Qn because it is 1. So we will write Qn. If it is 0, then we will write Qn bar. Okay. So we will write Qn here. And now at the top it is 0, 0. And at the top it is 1, 0. So what is the thing which is common? 0 is common. So we will write K bar. So it is Qn K bar. Okay. Now for this pair, again we will see at the left. So when we will see at the left, it is 0. 0 means what we will write? Qn bar. Okay. And now at the top, it is 1, 1 and 1, 0. So for this one, 1 is at first place. So what I am going to write? I am going to write J. So I have written here Qn bar J. So you have to remember this equation. Qn plus 1 for JK flip-flop is J Qn bar plus K bar Qn. You have to remember this equation to realize the gates from one gate to realize flip-flop from one flip-flop to another. Okay. Now the next is characteristic equation of D flip-flop and characteristic equation of T flip-flop. D flip-flop, it is very easy because we have only two inputs Qn and D. So there are 4 combinations. So if there are 4 combinations, then which K map I am going to use? It is 4 variable K map, 0, 1, 2, 3. It's 4 variable K map. It is really easy. So you can see here, where is the 1? It is at first and third. So I have written 1 here, I have written 1 here. And now we will make the pair, so that is the only pair we can form. So we will see at the left. At the left, if we will see, nothing is common, so I am not going to write anything. And at the top it is 1, which is showing D. So Qn plus 1 equals to D. That means whatever is my D, that is the Qn plus 1. As you can see from the table as well, 0, 0, 1, 1, 0, 0 and 1, 1. So that's my characteristic equation for Qn plus 1. It's very easy for D flip-flop. Now next is your T flip-flop. T flip-flop, do you remember the full form of T flip-flop? It is toggle flip-flop. And here again, this it's only the two inputs. That means we will use the 2 variable K map. That is, so it is 4 combinations: 0 0, 0 1, 1 0 and 1 1. Okay, so where are the ones? It is at first and the second place. So it is at the first and the second place. So see, we cannot make the diagonal pair. Please remember, we are not playing any tic-tac-toes and the Scrabble words. We cannot make the diagonal pair. This is the K map. So we have to make, this is the standalone pair and this is the standalone one, means it's a single one and the single one, right? So for this one, if we see at the left, it is Qn. So it is Qn. If we see at the top, it is 0. 0 means T bar. So it is T bar Qn. Plus, if we see at this one, at the left, it is Qn bar. It is Qn bar. And if we see at the top, it is 1. 1 means T. It is T. So what is my characteristic equation? It is T bar Qn plus T Qn bar. So you have to remember this characteristic equation as well. So we have find all the 4 characteristic equation of all the 4 flip-flops. These characteristic equations are very important in realizing the flip-flops from one form to another. Thank you so much. In the next slides, in the next presentation, I am going to cover the realization of JK flip-flop using the SR flip-flop. Thank you.